Hi, Algebra 1 students. Mr. Ramstad here again. Next, we're going to take a look at why the quadratic formula works. Where did it come from? Notice I got a little error in my quadratic formula. There we go. So the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And that, of course, works when we have our standard form quadratic equaling 0. So let's take a look at where this comes from. So our steps that we're going to take are going to get a little convoluted here. Bear with me. You're going to see that we get our formula at the end of this. But the basic idea as we go through this is I want you to make sure that you know everything we do to find this formula is a property of equality, the things we learned in middle school, and that the only restriction on the values of a, b, and c are that a cannot be equal to 0. And this is because if it was, we'd get 0x squared, and that would be 0, because 0 times anything is 0. And we'd just end up with b times x plus c equals 0. And that is a linear equation. And so solving that wouldn't give us the solution to a quadratic equation. So we just have to make sure we say a is not equal to 0 before we get started. So we have our equation already set up. A, b, and c are just some real numbers, some coefficients, and c being the constant. So the first thing we're going to do to find what x equals in this equation is let's divide both sides by a. And what that'll do for us is get rid of this leading coefficient off the x squared for us. Start to simplify our problem a bit. So a divided by a is 1. So we're going to write 1x squared. We normally don't write the 1 as a coefficient, but there's x squared plus, and then b divided by a times x, and then c divided by a equals, and then 0 divided by a is still 0, because 0 divided by anything is still 0. So our next step is going to be subtracting this constant value. We're going to get this onto the right-hand side of our equation because ultimately what we want to do is get x isolated by itself on the left-hand side of this equation. It could be the right-hand side, but traditionally we normally have x isolated on the left. So let's begin doing that with this little subtraction. We get x squared plus b over a times x equals, and 0 minus anything is just going to be negative c over a. Great. Now, here comes the trick, I'll call it, of solving this equation without any numbers here. Traditionally, when we see these quadratic equations, we like to factor them. We've seen in our previous videos, how do we factor this so that we can solve for x? And we're going to do a little technique called completing the square. So what we're going to do is try to make this left-hand side of the equation something that we absolutely know how to factor. But before we get to that, let's do a few example problems that we know how to factor already. So here are some expressions that we factored in the past. And they're a special type of quadratic expression that are known as perfect square trinomials. And let's see why. When we factor this, we get x plus 2 squared, right? In our second example here, in blue, we get x plus 3 squared. And that's why we call them perfect square trinomials, because they simplify to equal this quadratic trinomial. So how do we know how to factor them so easily is kind of a pattern. So in red here, we have that pattern, right? So we know that we are factoring a perfect square trinomial when we see something that looks like this, when a is 1, b is some number, but when the constant is half of b squared, right? So let's look at these examples again. Notice half of b, half of 4 is 2, and 2 squared is 4. And then when we factor it, it's just that half, right? Same thing happened in this blue example. Half of 6 is 3, and 3 squared is 9. And when we factor it, notice it's just half of that value. So we're going to take that same technique and force our quadratic to look like one of these perfect square trinomials. So that way we can factor it like this. So let's take a look here. Here's what we had written. So like we said, this thing we're going to place here is going to be half of this squared. So what is half of that? So let's take b over a and cut it in half. And let's just simplify this complex fraction a little bit. So that's b over a times the reciprocal of 2, which is 1/2. And let's multiply, and we get b over 2a. And now what we're going to do is square it, because that's our pattern in these perfect square trinomials. So let's just square this. And we're going to place that right here. We're going to add it to our equation. We're going to add b, and we're squaring it, so that's b squared. And then the denominator, 2a, we're going to square that, so we get 4a squared. And since we added it to the left-hand side of our equation, of course, we need to also add it to the right-hand side of our equation. That's the addition property of equality. We can't just add things randomly to our equation unless we also do it to the other side. Okay, so this is looking fairly complicated, but I assure you we're getting to some more simple tasks in a moment. We just created this perfect square trinomial on the left-hand side of our equation, and we know how to factor those. Remember that to factor a perfect square trinomial, we write our factor as x plus half of that middle term. And remember, we already found what half of it is. It's b over 2a. And then we square it. So notice now, all of a sudden, the left-hand side of the equation is much simpler. Now over here on the right-hand side of the equation, we're going to have to do something we all love. We're going to have to make sure we have a common denominator to put these things together. So let's do that. In fact, let's move this guy over just a tad. Our common denominator we're going to have as 4a squared. And to make that happen on this negative c over a, we're going to have to multiply by 4a over 4a. And that's just the number 1 written a little differently, right? So let's do that multiplication. We end up with negative c times 4a would be 4ac. And our denominator will now be a common denominator over 4a squared. Plus, and we get our b squared over 4a squared again. Okay. And because they have the same denominator, let's simplify one more time. The left-hand side of our equation is still hanging out over there. And let's actually put these guys together now that they have the same denominator. And I like putting the positive value first and the negative value as a subtraction afterwards. So we're just going to swap their places a little bit. B squared minus 4ac. Notice we're starting to see the beginnings of our formula, right? So let's continue. Oops, sorry about that. So let's continue here. Get rid of these little extras. Let's continue solving for x. I want you to notice right now, we've got something interesting. We have x in one single place in our equation. This is great. That means we could start isolating it. So to get rid of this squared on the left-hand side, what we're going to do is take the square root of both sides of our equation. Now I want you to be careful when you do this. Remember that when we take square roots, say the square root of 16, the answer to the square root is a positive and a negative number as well, right? So we got to make sure we do that. So on the left-hand side, we're left with just x plus b over 2a equaling positive and negative the square root of all of that. Boy. We're getting closer. Notice we already have the plus and minus. We have our square root symbol in there. Everything we've seen in the quadratic formula. Lastly, x is almost by itself. This is the only thing that's left in its way from getting isolated. So let's subtract it. Let's get rid of it from the left-hand side of the equation. Remember, we subtracted there. We're also going to have to subtract it on the other side of our equation. And let's simplify again. We finally have x equals something. Wow. Plus or minus square root of all that stuff minus b over 2a. Great. My a looks a little funky. Now, this is technically the quadratic formula. But we're gonna simplify it a bit, and you're gonna see we get what we've seen all along. Now, x, let's find a little bit of this square root really quick. We don't know how to find the square root of our numerator. It's a little too complex to find the square root of this. But notice our denominator, we are able to find the square root of this by finding the square root of 4 and the square root of a squared. And in fact, that is just 2a. We still have our plus or minus and our square root on top. We're getting closer. Minus 2b over 2a. Notice now we have two fractions being subtracted, and they both already have the same denominator. Wonderful. That makes life easy. So we're going to combine those two fractions together over one denominator. And we're going to put this negative b first and then our plus or minus just out of convention. It's just traditional to do that. We don't need to, but it is how we normally write our quadratic formula. So negative b, and then our other numerator, plus or minus the square root of b squared minus 4ac, and they already have that common denominator of 2a. And what do you know? We have actually derived or proven the formula to solve any quadratic equation. So I hope you learned a little there. It's okay if you didn't quite follow it. Go back, rewind, take a look at something. Try even deriving it yourself after you've seen the steps a couple times. And down in the description, see the link to my first video on the quadratic formula on how to use it. That's when it gets really powerful. When we get stuck and we can't factor something, this formula, because it was made from this factoring technique called completing the square, it lets us solve these equations even when we ourselves can't factor it. So with that, I'll see you next time.